All right, we were just talking about Fridays being fully remote for everyone, so make sure that you call in before noon or you post on the school website that you're in attendance. So don't forget to do that starting this Friday. All right, today we're going to talk about hydrogen and helium. We're starting on slide number 49, and we're going to 74, or that's the plan, as close to that as we can get. Viewers at home, I was just telling them I'm going to start trying to put the videos on my YouTube channel, and hopefully that'll make it a little faster and easier to view. I'm going to try that today. We'll test it out and see how it goes. All right, subatomic particles. Subatomic particles are protons, neutrons, and electrons. Those are subatomic particles. All atoms are constructed from these three subatomic particles. Protons, neutrons, and electrons. Remember, the electrons have almost no mass at all. When you're talking about the overall mass of an atom, the electrons are almost entirely empty space, so they do not contribute to the mass itself. Protons and neutrons are about the same mass as each other and are nearly 2,000 times heavier than an electron. Protons and electrons have equal and opposite electrical charges, while neutrons have no charge at all. A positive, no charge, and a negative. Protons and neutrons can be thought of as being stationary in the center. They just hang out here, and it's tightly packed in the center together. The electrons then are flying around the outside. In the center, they're called nucleons. So the protons and neutrons are called nucleons. The electrons move around so rapidly that their location isn't certain. They know pretty much where they're at, but it's not exact. It forms an electron cloud around the outside of the nucleus. Almost all the mass is in its nucleus. As you'll see, this diagram is not drawn to scale. They've shrunk it down so it'll fit on this page. Honestly, if we were drawing it to scale, it wouldn't fit in this room, wouldn't fit in this school. Okay? Protons have a positive charge, electrons have a negative charge, and opposite charges attract. What do the same charges do then? Repel each other. Correct. Imagining an atom in the size of a stadium. Almost all of an atom is empty space. Not air, but empty space. Because air, even the air in this room, has mass. Empty space is not the same thing as air. Imagine an atom to be the size of a football stadium. Its nucleus would be a pea, so if we dropped a little green pea right there in the center, that's how you would have to draw that to scale. Any electrons in this atom would be too small to be seen. These electrons are constantly moving through the stadium. It is an amazing fact that atoms are mostly empty space. This was learned just over 100 years ago. So really not that long ago, we did not even know that that was the case. Important to note, oh yeah, that's what I said, it's not air, it's empty space. Those are different things. The repulsion, so when they repel, of electron clouds within the atoms, since negative charges repel each other. Two negatives are going to push against each other. It's what makes matter seem solid. When you kick a ball, it's the electrons in the ball interacting with the electrons in the shoe, which provides the kick. Which of these has no electric charge? Roger, what do you think? Proton, neutron, electron, or I need help? No electric charge.
I know.
Okay, who can help him out? Gibbs, can you help him out? No? We only got one left, John. What do you think? It's got to be neutron, remember? No charge. Neutral, no charge. Electric, negative, and then positive. That's true. Which of these is found in the nucleus? Proton, neutron, electron, both A and B, or I need help? Connor, what do you think? Which one's found in the nucleus? What do you think, John? Both A and B, I agree. Protons and neutrons are in the nucleus. Electrons are on the outside. Which of these has a positive charge? Hires, what do you think?
Proton.
Proton is correct. Which of these has the least mass? Michaela, what do you think on this one? Proton, neutron, electron, both A and B, or I need help? Has the least mass? Michael?
C.
C, very good. The electrons, remember this is basically just nothing. This is where the mass is, the protons and the neutrons. Most of an atom is filled by nucleus, electrons, empty space, A and B, or I need help. Gibbs, what do you think? C, sounds good to me, and that is correct. Atoms and elements. Just to clarify, we want to point out that we will often use the terms atom and element interchangeably. That's a good thing to keep in mind. An element is matter comprised of all of the same atom. So the element hydrogen consists of only hydrogen atoms. One specific atom of hydrogen is a hydrogen atom. One or more atoms of hydrogen form the element hydrogen. So they're giving you examples of how the terms element and atom basically mean the same thing. So they may say atom one time and element the next because they basically mean the same thing. Hydrogen and helium. Together, hydrogen and helium make up 98% of all the matter in the universe. Consequently, what are the atomic numbers for hydrogen and helium? Anybody know? Izzy, you can see it. Hydrogen and helium, what are their atomic numbers? One and, what's helium? 2. 1 and 2, so the first two. Hydrogen makes up 74%, helium 24%. That only leaves 2%, so this teeny little amount, for all of the other elements. Hydrogen is colorless, odorless, highly flammable. Hydrogen atoms normally consist of 2 particles, 1 proton, and 1 electron. So its atomic number is 1 because it has 1 proton. At the beginning of the universe, protons and electrons came together to form most of the first atoms in the universe as hydrogen. Today, 74% of the matter is still hydrogen. Atomic number. The atomic number is the same as the number of protons. So atomic number is 1. So John, how many protons does it have? 1. Very good. Every hydrogen atom has exactly 1 proton. If an atom has 1 proton, it's hydrogen, and the symbol is a capital H. Atomic number of hydrogen. We'll learn later that a hydrogen atom could gain or lose an electron. Okay, the goal for all elements is for there to be a stable amount of electrons. In order for those electron numbers to be stable, they gain electrons, they lose electrons, share electrons, or pool electrons. So they get rid of one, take one in, share them with something else, or throw them in a big pile together and share them. It could also gain neutrons and become a different isotope of hydrogen. So if it gains neutrons, this is important, it becomes a different isotope. An element is not defined by its number of electrons or neutrons. So what is it identified by then? By its number of what, Grant? No. Michael? Nice job reading ahead to the next line. But by the number of protons. Although a neutral atom will have the same number of protons and electrons. As long as an atom or an ion has 1 proton, it is hydrogen. Okay. Helium is normally made of 6 subatomic particles. Dakota, tell me what the 3 subatomic particles are. Yes, you do. What are the subatomic particles?
What?
What are the 3 subatomic particles? What is it, Izzy? Protons, neutrons, and electrons. Very good. So helium has 2 protons, 2 neutrons, and 2 electrons for a total of 6 subatomic particles. The atomic number of an atom is its number of protons. So the atomic number of helium is 2. So it has 2 protons. Every helium atom has exactly 2. If an atom does not have 2 protons, it's not helium. If an atom has 2 protons, then it is helium, and its symbol is He. Atomic number of helium. Although helium atoms on Earth do not gain or lose electrons to form a helium ion, that does occur in the Sun's atmosphere at above 60,000 Kelvin. Helium, or Kelvin, is just a unit of really high temperature. Helium can also have different numbers of neutrons to become different isotopes of helium. Atoms are not defined by the number of electrons. They are defined by the number of what, Gibbs? Hires? Protons is correct. But by the number of protons, which is equal to the number of electrons in a neutral atom. The most common element in the universe is, Connor, helium, hydrogen, lithium, carbon, or I need help.